In earlier videos, we looked at creating charts in Altair as x equals some column and y equals some other column. As it turns out, that's actually a shorthand. The longhand version is that the x and y parameters take alt x and alt y methods, and these methods then have parameters themselves that we can use to create more complex graphs. The easiest way to start thinking about this is to look at a histogram. A histogram is a bar chart that shows the distribution of a particular set of numerical data. Here we're going to use Seattle weather again because it's so handy. We perform our usual imports and we read the Seattle weather data from the CSV that I saved 2 videos ago, something like that. Now we'll just take a look at DF just to remind ourselves of the categories and columns that are there. So we can start by creating a bar chart. C equals alt capital C chart. Takes DF as a parameter, mark bar, encode x equals temp men, and we'll set the y value to count, which implies count x, right? So you count the instances of temp men, and that comes out fine because in this case there's a discrete number of minimum temperatures that are in the data set. So you see a kind of a histogram as a result. We'll add a tooltip as well. Tooltips are marvelous. They're one of the great things about interactive charts that you don't get with a chart on paper, where you can hover over a mouse and see a value. Can't hover a mouse over paper. That would be ridiculous. Anyway, we can change this into a proper histogram by editing the chart, and where we had just x equals temp min before, we're going to change this to x equals alt x temp min, and alt x has a parameter called bin. We'll set bin to true, close the bracket, hit shift and enter, and voila, here we have a histogram as we recognize it. The bars are a little thick on that histogram, so we set bins equals to alt bin, which itself has a parameter called max bins. Set that to 50. Close, shift and enter runs it. And there we go again, a proper histogram. Read the values with the tooltip. Marvelous, just marvelous, and so quick, so very quick. Now, the histogram shows you where the weight of the data is, and the reverse of that, the chart that shows you where the outliers in data are, is a box plot. Altair, which is, or Bokeh, which is Altair's biggest competitor, doesn't have a box plot natively. You have to make an effort to make a box plot. But here, there's a mark box plot method, just like there's mark line, mark bar, mark ek, mark arc, and all the rest of them. So here we set x to temp men, close the bracket, and hit shift enter, and it runs just like that. Of course, yeah, I have to remember to print C to see it. That was a bit slow of me. But anyway, that's our box plot of the data. Now, if we look at a more data with, or a datum with no data, if we look at data with more outliers, we can see them. We can see this big mass of outliers stretching out there, and I'm so impressed by this. We can use a tooltip to identify the particular outliers. It's such an easy way to identify outliers in data graphically that the tooltip recognizes the outliers. So you can just hover your mouse over a particular outlier and say, my goodness, I wonder when was that? And you find out it was in December sometime. When you hover over the box itself, you see the interquantile range of the 5-number summary on which the box plot itself is based. It's just completely marvelous. As well as that, we can divide our box plot by a categorical value. So we set y to year, and here we see box plots that precipitation data broken down for each particular year. It's absolutely marvelous. Next up, we look at dressing up these plots a little bit. Please click like, subscribe, and notify to keep the videos coming. Live long and prosper.